Hey everyone, it's Justin again. In this lesson, we're going to be taking the standard form equation of circles and working backwards. Instead of being given an equation like you were in the last lesson, our goal is going to be to write an equation. By the end of this lesson, you will be able to write the equation of a circle in standard form from a graph or given points. First, we'll review the standard form equation for circles. Then, we'll complete 2 example problems. In order to write the equation of a circle, let's review what information we're going to need to be able to do that. Here is our standard form circle equation. Since x and y will always just stay as x and y in any specific equation, to write the equation of a circle, we only need the values of h, k, and r. Do you remember where we can get these variables from? We can get h and k from the coordinates of the center of the circle and r from the radius. Let's see what this looks like in a couple of examples. Our first example asks, what is the equation in standard form of the circle shown on the graph below? We also have a graph of a circle. To write its standard form equation, we're going to need the coordinates of its center and the length of its radius. We were told that the center is point C. So what are its coordinates? Point C is at -4, 3. Before we put this into the standard form equation, let's look at the radius. If the center of this circle is -4, 3, what is the radius? Since we have the center, the easiest way to get the radius is to use the same method of finding points as we did when we were graphing circles. Start at the center and move directly right, left, up, or down to find a point on the circle. If I move straight to the right, I wind up at this point. Since I moved directly horizontally, I can count and see that this distance from the center to the point on the circle is 4 units. If you'd prefer, you could also use the distance formula to find the radius instead. Now that we have the center and radius, pause the video and try to fill in the standard form equation. From our center, we know that h is -4. If I put that in the standard form equation, I get x minus -4 squared. And I can simplify this expression to just x plus 4 squared. From the center, we also know that k is 3. So that gives us y minus 3 squared. There's nothing to simplify there, so we could just move on to r squared now. Since r is 4, r squared will be 4 squared, or 16. X and y stay as they are, so this is our final answer. Let's do one more example. Our next example problem says to write the equation of a circle whose center is 3, -2, given that the point 1, 2 is on the circle. Give this one a try on your own. Pause the video here and see how far you can get in this problem independently. To write the equation of a circle, we're going to need the center and the radius. Did you notice that we were just given the center? That's convenient. Now all we need is the radius. In the last example, we were able to use a picture to just count the radius by hand. If you were to look at the graph for this circle, though, you could see that that's not going to be possible because the points directly to the right, above, below, and left of the center are not on integer coordinates. I can see that the radius is... Well, it's between 4 and 5 units, but I can't say exactly how many units, so this won't work. I do know the exact coordinates of one point on the circle, though, 1, 2. So I can use the distance formula to find the distance between the center and this point on the circle, 1, 2. If you were stuck figuring out the radius before, pause the video now and use the distance formula to find it on your own. For my distance formula, I used 3, -2 as x1 and y1, and 1, 2 as x2 and y2. If you substituted them in as the opposite way, that is totally okay, and you will still get the same answer as me. I also clarified in my equation that this distance represents r, the radius. Now, I can simplify as much as possible. So, my radius is going to be the square root of 20. It's always a good habit to simplify your square roots, and since 20 is 4 times 5, I can pull out the 4 and make this 2 root 5. Now that we have everything we need, let's go ahead and fill in our equation. Since the center is 3, -2, we can fill in h and k in the equation, simplifying the y minus k expression to get y plus 2 squared. Then I'll fill in my radius, so r squared becomes 2 root 5 squared. This is a little tricky. Squaring 2 root 5 means doing 2 root 5 times 2 root 5. 2 times 2 makes 4, and root 5 times root 5 makes 5. Now all that's left is to multiply 4 times 5, and we get a final value of 20 for r squared. Hey, wait a second. When I finished my distance formula a little bit ago, I got that r equals root 20. If you're dealing with square roots in a case like this, where you're just going to square your answer anyway, you could take a little bit of a shortcut and just not simplify the square root. And now we have our final answer for the standard form equation for this circle. To write the standard form equation of a circle, you need the center and the radius. Be on the lookout for the different ways you can find this information. The center could be given in the problem, or you could find it on a graph. For the radius, it could also be given. If it's a whole number, you might be able to count it on a graph, or you can always use the distance formula between the center and any point on the circle. Keep all of this in mind as you move into your practice game. Good luck, and I'll see you next time. Hey.